Okay, so just like the last question, we want to solve for t, but because t is in the exponent, we need to do that with logarithms. Since the base of our exponent is e, natural log is the best choice. I started with x. I don't know why I started with x, because if you start with y, you don't have to start by dividing by 2 here, but then we will actually have to divide by 2 later, so I don't know what works best. So I started with x, which meant I have to divide by 2 first, because I need to isolate the exponential. So I did that, and then I take the logarithm of each side, use the power property to move the exponent to the front. The natural log of e equals 1, so negative t times 1 is negative t. So that equals our beginning part, natural log x over 2, because this was just all my work in here. Okay, so I go back to this, and I've got negative t equals that. So that means positive t equals negative natural log x over 2. So we've solved it for t, and now we want to plug that into our y equation. So I'll take y, tried to change colors, and it didn't cooperate with me. So e, now it's going to change colors. Take that, and we're going to plug in the negative natural log x over 2 in there. And that is going to, well, the negatives cancel each other out first, which is very nice. So we have e 2 natural log x over 2. And then I'm going to put this 2 back over here as an exponent. So I'm kind of undoing that whole simplification process. So that would be e natural log to the x over 2 squared. And then, just like natural log of e turns into 1, e of natural log turns into 1. So these go away, and we are just simply left with y equals x over 2 squared. So y equals x squared over 4. So y equals, actually 4y equals x squared, which is another parabola. This time it's a function. It's going upward. The thing is, our restriction on t means that it's only going to be a teeny little piece of that parabola. If you look back to what we did in our previous section, you'll be able to see the graph we did there, and it's just a teeny tiny little piece of that parabola. I don't know if you want me to sketch it for reference or if you have it handy. Yeah. Yeah, I think so. So it's just this little portion of this parabola. So this parabola would be at 0, 0. And it would just be, oh, it would be stretched by a factor of 4, right? So instead of going over 1 up 1, it would be like over 1 up 4. No, wait, it would be the other way around. Because if we divide by the 4, if I go back to what we were doing in the last section, then it would be the focus, or not the last section, but the last example. The focus would be up 1, and the lattice rectum would be from here to here. That's where we want to go. Okay, so that would put the whole parabola in about here-ish. But this graph itself is only going to be one little teeny piece because it's going to end at 2, 1. So over 2 up 1. That's as far as it goes. This was a weird one we did last time, and the orientation of the graph went that way. So just as kind of a reference for what we did last time. So again, when you eliminate the parameter, it becomes harder to know that you're just going to have a piece of it without being very specific about where that piece starts and ends. Like you would have to say, oh, x starts at, well, it starts at 2, 1 and ends at 0, 0, right? Starting and ending points. But it's along that parabolic path of this equation.